class, and welcome to lesson 7.6 geometric series. Just a reminder, guys, that what we've been working on in this combined 7-8 unit is discrete functions. Okay, so notice when we've been given a sequence or a series that the numbers have had a significant pattern, either a common difference, which would make it arithmetic, or a common ratio, which would make it geometric. We've also discovered that a sequence has commas, where a series has plus signs. All right, so today we're going to specifically focus on geometric series. So a geometric series is the sum of the terms in a geometric sequence. The best way I could describe this, ladies and gentlemen, is say we get an inheritance that we're going to put in for maybe an RSP. So say we got $1,000 and we're going to put it into an RSP. And each month or each year, depending on how you set that up with the bank, you're going to get interest earned on it. Okay, so say for the first month you might earn $50. So what do you notice is that the first month you're going to have $1,000, and then you're going to add 50 to it, and then maybe the next month you have $52, so then you add that and add that. So a geometric series is kind of like an investment plan where you know you're going to be building interest on top of that, and it's going to be totaled up because you want to know how much your investment holds, right? So that's the best way I can explain a geometric sequence. Okay, let's just compare in these examples below the difference between a geometric sequence and a geometric series. Well, first of all, remember, guys, a sequence has commas. So notice in the list of values, it's comma. There's commas in between them. Whereas in a series, we have plus signs, right? And then how do we tell that it's geometric versus arithmetic? You have to take a look at the patterning. What's happening in each case? So in each case, this is a doubling, which means we're timesing by 2. So that says R equals 2, and that happens in both these cases. And just remember, guys, that we always have the first value in our sequence or series become the letter A. So in this case, A would equal 1. And that's significant for putting into formulas. All right, so here is the general term for the geometric sequence. And remember, guys, S and N tells us it's the sum of the numbers, okay, the sum of the terms, okay? So the sum of the first n terms in a geometric sequence can be calculated using either formula. So the first formula is where you've got the n value, so you can sub that in. The second formula, this looks kind of funny, ladies and gentlemen, but if you think about this expression here, r times t to the n is usually one of the values given, but if you times it by r, that represents t to the n plus 1, because it's the next one in the series, simply because the ratio is being applied to it. All right, it's another way to think about it. If you're worried about where these formulas came from, please see page 455 in your textbook. Again, folks, for your unit test, I'll provide you these formulas. You just have to know how to recognize which one. And how do you recognize this? First of all, S at N, that tells you it's got to be a series. Okay, so that tells you series, and T at N will tell you sequence. And in this formula, we have R, which tells you there's a common ratio. That means it's geometric. If you had a D in the formula, that would be a common difference, and that would be arithmetic. So those are the 4 ways, or the ways to separate your 4 formulas. Okay? The only restriction we have, ladies and gentlemen, with this formula is R cannot be equal to 0, simply because if you remember back to when we did rational expressions, the denominator cannot equal 0. Okay? And just think about it, guys. If R was equal to 1, okay, so if I started with 1 and you times it by 1, what is that going to give you? 1. And you times it by 1, you're not going to get a significant series here because guess what? The values stay the same. There's no change in the pattern, so that's another way to think about it. All right, let's try example 1. Example 1 says to calculate the sum of the first 15 terms, so that tells us n equals 15, and it says of the following series. Okay, so looking at our series starts with -2, so that tells us A equals -2. And we got to see what's happening each case. Be careful here, class, when you notice that the signs flip from positive to negative. You're going to notice that, hey, every time we're going to multiply by -2. Okay? Multiply by -2. So in this case, our R, be careful with that one, R equals -2. Okay? If you're not sure again, you can take the last value, subtract the one before it. So if you're not sure, R equals -32 divided by 16. Plug it in your calculator and you'll get R equals -2. It's another way to look at it if you're trying to figure that out, if you don't see the pattern. All right. So what the question asks us, it says, hey, what is the sum of the first 15 terms? So we're looking at S at 15. So what does that equal? Well, what information is given? We're given N, and we've got A and R, so we're going to use the first formula here. So I'm just going to write it out. So S at N equals A times R to the N minus 1, all divided by R minus 1. Subbing what we know in, so we've got S at 15 equals A, which is -2, times R, which is -2, all raised to the N, which is 15. And subtract 1. All divided by R, which is -2, subtract 1. Okay, let's do some simplification here, guys. So S at 15 equals, well, if you take a look, just plug in your calculator. Well, you can simplify things out. You notice you're going to have -2, so you know it's going to be a negative divided by negative, which is then going to have times it by negative, so you're going to have a negative result. But if you total the numerator, plug it in your calculator, you're going to get 65,538 divided by -3. Remember, guys, it's improper to have the negative on the bottom, so you've got to bring it up top. And then divide by 3, so you should get 21,846. Now check, ladies and gentlemen, about the sign. If the first value is negative and it's an odd number, and you're looking for an odd sum, you know the result has to be negative, so that's correct. Okay, and then do a therefore statement. So therefore, the sum of the first 15 terms is -21,846. All right, that was an easier example where it was a straight substitution. Let's get into a harder one. Okay, so this one's an example 2 is a little harder. It says to calculate the sum. That tells us we're looking for a series. We're given the first value. So the first value, ladies and gentlemen, is A. So A equals 7,971,615. Okay. But we're not given the N value, are we? We don't know what N is, do we? Okay. So what we're trying to find is S at N. So we're trying to find the sum. Okay, we don't know how many numbers are in the digit, but we do know the last value. Okay, and remember the last value is your T at N. So T at N equals 92,160. So what we know is this is getting smaller in the ratio, so the ratio should hopefully be less than 1. Looking at these numbers, it's pretty hard to figure out how to do this. Just remember when you're trying to find R, you can take T2 divided by T1 or T3 divided by T2, as long as you take the one from the right divided by the one from the left. Okay, so let's plug it and use the fraction button in your calculator. So I'm going to say for T2, that's 5,314,410. Fraction button, and your fraction button should look like A, B over C, right? Let me make that bigger, sorry, for those people who can hardly see. So use your fraction button. So A, B over C. Okay. And divide that, or use your fraction button and over 7,971,615. And using the fraction button, guys, you're going to get r equals 2/3. That makes sense that it's less than 1 because our numbers are getting smaller. So r equals 2/3. Okay, so looking at our formulas, ladies and gentlemen, if I scroll back up, can I use this original, the first formula here that I'm going to star in the red? Can I use that one? I can't because I don't know the value of n. So this is the situation where I have to use the second formula because t at n's given, which is really your last term. So we're going to use that formula. I'll just write it out here for those people who need to see it. So S at n equals a times r. Oops, sorry, my fault. Back that truck up. Apologize. Looking at the wrong formula for a second. So S at n equals r t at the n minus a. Okay, divided by r minus 1. Sorry, just give me a second.
We've only just got notification that the buses from Seaforth to Clinton
Sorry, guys.
are not running. Clinton buses are running, but it does mean that you will be working with limited class.
Sorry, guys.
However, classes should continue to run as per usual, and we apologize. The message did not get passed on to us, therefore we're only just finding out right now.
Okay. Sorry, guys. Bus delay. I guess some of you aren't coming in today. Sorry.
Ms. Carter, please call extension 160 for a phone call. Ms. Carter, please call extension 160 for a phone call.
This is what happens when I try to do lessons before class. But anyway, you guys are hopefully still with me. Let's finish this off. Just remember, guys, this is a divide by line, so you've got to do everything in the numerator first. So r is 2/3 times t at n, which is your last value, which is 92,160. And then you subtract it from a. Whew, I'm not going to be able to fit that in. Let me just see if I can squeeze it in a little smaller. Okay, so subtract 7,971,615. Sorry, guys, about that. Thought I had more room. And then r, which is 2/3, subtract 1. Okay, so I'd be using my fraction button here when I'm pressing 2/3 into our formula. So let's get, plug it in your calculator. As long as you got your brackets in, you'll be fine. And believe it or not, the sum of this is 23,730,525. Okay, and again, it didn't ask for the term number, it just said calculate the sum. So say therefore, the sum is, again, 23,730,525. All right. If they had asked you, ladies and gentlemen, to find the term number, how many terms are in this sequence, then you just go back to using your geometric sequence with your t at n and your r to find a. Okay? You may have a homework question like that. That's why I thought I'd preface that with it or talk to you about it. So here's your homework, ladies and gentlemen. Page 459, 1A, 3D, BD, 4, 6 ACF, and 11. And ladies and gentlemen, next day we're going to start our financial part of the unit. So we're going to be shifting to Unit 8. I just wanted to make sure we've got these formulas down packed so then we can apply them when we get to the financial math section, which is coming up next, because financial math is also discrete function. That's why we group these together. Have a fabulous day, guys, and as always, you know what I'm going to say, come see me if you need some help. Have a great day, guys.